Good morning. Today we're going to be talking about lesson 8, which is natural log. This is going to be something brand new to you. So a couple different things. What is a natural log? So E, okay? E is actually a number. It's not a variable. It's approximately 2.7, give or take. There's going to be a video that you need to watch that has information about what this really means in real world applications and such. So E is a natural base. For example, you can write it as e to the x. Remember, e is a number. It's not a variable. Okay? So base e, they're called natural logarithms. And the way that you get a natural logarithm is when you have log base of e to the x. Okay? So for whatever reason, when they have log e, instead of leaving it as log e, it's rewritten as something called ln, which is your natural log. Why the letters are flipped, I have no idea, but they are. You can find this button on your calculator. Hang on, let me show it to you. Okay, and it's this button right below log. Okay, so when you're going to solve it, you would just type in natural log of whatever number and you would find a variable, or a number, excuse me. Okay, so your natural log will replace your log base e. Okay? So first thing that they want us to do is just go through and rewrite things. So just remember how to go through and rewrite it. So if we look at number 1, we have e to the x is equal to 24. They want you to rewrite this in logarithmic form. This becomes your base. You're going to get log base e of 24 is equal to x. Okay, whenever I have log base e, that gets rewritten as natural log of 24 is equal to x. And this would technically be your final answer. Okay, let's look at number 3. Number 3, we have e to the x plus 5 is equal to 72. We're going to rewrite this as log base e of 72 is equal to x plus 5. Okay, remember your log base e is written as natural log of 72 is equal to x plus 5. Now they would like us to go in the opposite direction. So if we were to look at number 4, for instance, on number 4 you have natural log of x is equal to 58. Your natural log of x is the same thing as log base e of x to 58. And now you can rewrite this as your base e is your your e is going to be the base to your 58. And then you get e to the 58 is equal to x. And then you can actually plug that into your calculator to figure out what x is equal to if it asked you to. If you ever was solving for e, to find e on the calculator, you would do second natural log. And we could type in our 58. And you would get this decimal, which is gigantic because you have e to the 25, which would move over 25 places to the right. Okay? Let's look at number 6. You get the idea. Number 6, we have natural log of x minus 9 is equal to 32. Once again, your natural log is the same thing as log base e of x minus 9 is equal to 32. We would take my base e and it becomes your base to your 32 and you get e to the 32 is equal to x minus 9. I guess I should enlarge the screen for you. Okay, next thing that they would like us to do on number 7 is condense. That means they want you to take it from 2 natural logs into 1 natural log. Now, natural logs are actually going to follow the exact same rules as your logarithms. So if there's an addition sign, you would rewrite this using multiplication, and this would become natural log of 3 times 16, which is natural log of 48. Okay, if we look at number 9, same concept. You have 1/3 times your natural log of 64 plus 2 times natural log of x. Step 1 is I don't like these numbers in front. They're going to become exponents. So I'm going to get natural log of 64 to the 1/3 plus natural log of x squared. 64 to the 1/3 is 4, and your natural log will stay of x squared. Once again, when we are adding, you would rewrite it as multiplication, and you get natural log of 4x squared. Okay, number 10, they want you to go through and expand it. That means we have natural log of 5x. They want you to go from 1 natural log to multiple natural logs. Okay, so when there's multiplication, you can rewrite this as addition, and you would get natural log of 5 plus natural log of x. Okay, now if you were to look at number 12, for instance, you're going to get the natural log of the cube root of m squared n. First thing that you could do is you could rewrite this as n squared n raised to the 1/3, because this has an x. This whole thing is being raised to the first power. You then would distribute your exponent to both of these pieces, and you'd get natural log of m to the 2/3, because 2 times 1/3 is 2/3, and n to the 1/3. You would then rewrite this with addition because you're multiplying. So you get natural log of m to the 2/3 plus natural log of n to the 1/3. And then lastly, we don't like exponents, so my 2/3, my 1/3 go out front. I'd get 2/3 natural log of m plus 1/3 natural log of n. Okay, from here on out, they want you to go through and solve. So for solving, you're going to follow the same general protocol. That means I need a natural log equal to a natural log, or I need a natural log is equal to a number, and you would, I don't know why I wrote number 2, equal to a number, but it follows the same guidelines as we did with solving for logarithms. You still need to check for extraneous solutions because you need to be able to go through and double check that it gives you a positive number. So if you look at number 13, for number 13, you get the natural log of 4x minus 27 is equal to the natural log of 15 minus 2x. If you notice, I have a natural log on the left and a natural log on the right. I have one of each. My natural logs will just cancel out, and I'll get 4x minus 27 is equal to 15 minus 2x. And then we'll just go through and solve for x. I'm going to add my 2x and add my 27. And I'll get x is equal to 42. So when I divide both sides by 6, you're getting x is equal to 7. Now you need to plug this 7 back in up here to make sure that the left side and the right side are equal to each other, but you also need to make sure that your natural log is a negative number. So if you were to plug back in 7, you get natural log of 4 times 7 minus 27. And you get 28 minus 27, and you get natural log of 1. So if I check the other side, you get the natural log of 15 minus 2 times 7. You get natural log of 15 minus 14. So you get natural log of 1 equals natural log of 1. So it means your final answer was, in fact, 7. All right, let's try number 15. We get natural log of 72 minus natural log of 4 is equal to natural log of 6 plus natural log of a minus 2. So if you notice, I have 4 logarithms. I can only have one on the left, one on the right. So in order to combine these, when you have subtraction, that means we would rewrite it as division. So you're going to get the natural log of 72 over 4. On the right side, when there's addition, you rewrite it as multiplication. You're going to get 6 times a minus 2. Since I have a single log on the left and a single log on the right, my natural logs can cancel. 72 divided by 4 is 18. And if I distribute, you get 6a minus 12. I'm going to add 12 to both sides, and I'm going to get 30 is equal to 6a. So that means a is equal to 5. When you go to check this back in, there's no a's on this side, so I don't have to check it. Over here, 5 minus 2 is 3. So that means technically you would have to rewrite this. And you get natural log of 18, which is what you would get on the other side when you divide your 72 and your 4. So they check to be the same, so a is equal to 5. Now 17 is where you have to remember the different rules. So you're going to get natural log of 8x is equal to 2. So to get started, I have natural log equal to a number, which is one of the cases that you can have. When you have this, that means you need to rewrite it from your log, in air quotes, I totally just did air quotes, we didn't see them, but you need to write it from your log into your exponential. We know that the natural log is the same thing as having log base e of 8x is equal to 2. You can then rewrite it as e squared, that's a 2, e squared is equal to 8x. And then I need to divide everything by my 8 so that I can figure out what x is actually equal to. We're going to jump into our calculator and we're going to plug this in. Okay, so I'm going to start by doing alpha x to get my fraction button. I'm going to do second natural log squared, and then I'm going to divide this by 8, and I'm going to get an answer of x is approximately 0.9236. So as you are solving with natural logs or logs, you still need to make sure you're rounding to 4 decimal places. So if I were to plug this back into my calculator, I would do natural log of 8 times my last answer. So you'll do second negative sign, and I need this to equal 2 because that's what my equation says, which it does equal 2. So we know that that answer of whatever that decimal is did in fact work because I checked it in my calculator. Okay, let's look at number 19. So on number 19, we have e to the x is equal to 57. I still need to go and solve for this one. Since my x is in my variable, since x is my variable and it's in my exponent, that doesn't help me. So I need to get my x out from there. So there's a couple different ways that you could do this. I cannot take the log of both sides because I can't have log of e. I would need to have log base b. So I'm actually going to go through and rewrite this in log form. So e is my base. I'm going to get log base e of 57 is equal to x. And the reason I did it this way is because I need to get my x out of my exponent. I cannot take the log of both sides because I can't have my e not in my base. Because e is a number and it's hard to, you can't solve it like that. Okay? So I rewrote it from exponential to logarithmic form. We know that log base e is the same thing as natural log of 57. And that's what I'll plug into my calculator. So I will go to my natural log of 57 and I got my answer of x is approximately 4.0431. If I were to plug this back in, I would do second natural log, second negative sign, and this would need to equal 57, which it does. So my answer did check to work. So my answer would be that decimal. All right, let's try one more for you. I have 5e to the 4n is equal to 95. I need to get the e by itself, so I'm going to start by dividing that 5 to both sides. So I'm going to get e to the 4n is now equal to 19. Once again, my variable's in my exponent, so in order to move it from the exponent, I'm going to rewrite it in logarithmic form. I'm going to get log base e of 19 is equal to 4n, and then I need to get the 4 on the other side, so I'm going to divide both sides by 4. I can rewrite my log base e as natural log of 19, divide that by 4, and let's see what my decimal is equal to. So I'm going to go to my calculator, I'll go to alpha x, I'll do natural log of 19, and I'm going to divide that by 4, and I get an answer of, and is approximately 0.7361. If I check my answer, I would do 5 second natural log of 4 times my last answer, and I need that to equal 95, which it does. So my final answer is 0.7361. Now these are a little bit more challenging, so try these out, and then if you would like for me to go through any others, please let me know. Other than that, hope you have a good rest of your day and make sure you are following the calendar. If you have questions, feel free to let me know. If not, attend the conferences. It's just a question and answer session if you have any questions. Hope to see you all there either tomorrow or later in the week, depending on what class hour you are. All right, guys. See you later.